Keep in mind that in our POA, sorry, AOM, all right, the aircraft does say it recommends by experienced pilots a maximum of 15 degrees crosswind, all right? Now, it's a recommendation. There is no crosswind limitation. If you think you can do it, you can give it a shot. But experienced pilots with over 5,000 hours have said 15 was the max. Okay?
Like that, 15 on the board? Or?
Well, here's the thing, right? So if we go right here in the middle, right, to the 40-degree line, and then 15 degrees here, then you just go across. You see, so that will be about 10 knots headwind, okay? And then when it comes to your crosswind, it will be around 10-ish. Make sense? All right, so that's how you use this chart. This is basically to tell you how much of a headwind we have, okay? Now, the takeoff chart still takes your pressure altitude into account. All right, knowing the height of the field is important. No, all right. Pressure altitude is the altitude that the altimeter is reading. We already talked about it, all right? Pressure altitude is the standard, all right? So I would say no need to write this equation down if you have a CX3, all right? But you can, okay, let's write the pressure altitude equation actually, okay? So the pressure altitude is the standard minus the actual, all right, which we have 29.92 minus 29.6, all right? That is not the end of the equation, just a heads up. All right, afterwards, whatever number you get, you times it by 1,000. All right. Okay, just work. What are you? Where are you? What did you get?
No, I'm writing it in.
Oh, okay. Okay. Cool. All right. Because you get 320 at the very end afterwards, you will need to add that. All right. And so technically your pressure altitude will be 3,400 feet. All right, this formula makes sense. I hope, all right? If it doesn't make sense, then just memorize it. But here is the thing. If you have a CX3 with you, all right, technically you could do it on the calculator. It will be much more accurate. And if you do it on the calculator, all right, you will probably get slightly different numbers than what we are getting over here, all right? This is just an estimation as to when you don't have the actual calculator for you, okay? Cool. So this is what a takeoff chart looks like, all right? You should always start by reading from the very top. So you have your notes over here. All right, this is for a short field technique, all right? Prior to takeoff, about 3,000 feet, the mixture should be lean. Okay, so that's a very good note for us to read. To give you a maximum RPM in a full round, static round. Okay, so make sure we'll do that. Decrease distance by 10% for each 9 knots of headwind. So we have 12 knots of headwind, so we'll have to reduce the distance by about 10%. Okay? And then for operations on dry grass, increase the distance by 15% of the ground roll, all right? Which we will talk about. So for us right now, we are at 3,400 pressure altitude. And it does say exactly what it's looking for, right? Pressure altitude. So when that happens, right, just pick something in the middle. It doesn't have to be 100% accurate. You can make it as accurate as you can, but that takes a very long time, right? Just choosing. So for us, we're going to say it's 3,005, and we're going to choose something in the middle between 3,000 and 4,000. Okay? After that, our temperature, we said, was 20 degrees. So you go to the 20-degree line. Okay? Simple enough. If it was 15 or something, then you can pick between the both numbers of 10 and 20. All right? So for us specifically, all right, because we're choosing from between 3,000 and 4,000, okay, we always have over here what they call the ground roll. This is what you need if you don't have any obstacle. If you do have obstacle, then you will be using the total to clear 50-foot obstacle over here, all right? You do need both numbers each time you're doing a takeoff distance, and you will need both of them for the exam, all right? If we are departing Pitt Meadow and we are landing in Vancouver, for example, all right, you will still need to give the takeoff distance for Vancouver, all right? Even though you're not taking off from there, you can't get the airplane stuck. You can't just be like, all right, well, I can land, and then whenever I take off, only then you figure out you can't take off because you don't have distance, okay? So you have to figure out both before you fly, even if you're just landing there, okay? So figure out what's the middle point. So it will be 1230 plus 1355. Divide that by 2 to get your average. And then that is what you would be getting. Ground roll will be 1293 and the total 50 foot will be 2433. All right? Good.
Are you able to more light lessons?
Good. Now, for the takeoff, so continuing on. So keep in mind, this is the numbers we got, right? Let's actually write that down on the board here. So we have 1293 and 2433. Now the wind, like we already said, plays a big part of it, right? So with a 12 knots headwind, now this equation is very, very, well, it seems like they're trying to make it really complex, right? If I were you guys, I would just round it to 9 knots, right? We were at about 12. We already know the runway is good enough, right? So I would just say 10% instead. And but again, you can really do the calculation if you want to be really accurate. All right. So for us, let's just take 10%. All right. So if we do 10%, so that'll be 1293 times 10% equal 129. All right, plus 129.3 equal all right, 1422. All right, so that, sorry. We have to minus it. We are reducing the distance, right? So we made a mistake. Minus 129 minus 129. So it will be 1164. Okay? And then you would be doing the same thing for the for this one. Okay.